Hello everyone! Today we'll talk about the solution to the problem grid game. It's quite a cute problem because you look at it, if you're like me, you see it's a 2 by n grid, but we can only go right or down. We are having some points, we are eating up those points, and so it's clear how to maximize the number of points that the first robot will eat. That's because the first robot will be going on the first row for some while, and then going down and continuing on the second row. So he'll be eating, assuming that he goes down on position I, he'll be eating everything up to I inclusive from the first row and everything from I inclusive from the second row. So we have a prefix sum on the first row, suffix sum on the second row. This is the best score for the first robot. But here there is of course the second robot. The second robot goes after the first one, so nothing that the first one has eaten is available for the second one. And of course the first one wants to minimize number of points that the second robot collects. The second robot will want to maximize. And of course we have to return the number of points that the second robot collects. And again, if you're like me, you might think that, well, let's maximize the number of points that the first robot gets, and that's the solution. Well, it's not the solution, and it's not the solution because the first robot will be taking some prefix from the first row and some suffix from the second row. And it's not like the second robot can take everything that's left. That's because what's left is some prefix of the second row and some suffix of the first row. And actually, not only are those just any prefix and suffix, it's a prefix of the second row that ends before the suffix of the first row starts. Which means that not only can we not, as a second robot, eat everything that remains, we can actually only take either something from the top or something from the bottom, but we cannot take both something from the top and something from the bottom. Which means that actually there are only two strategies for the second robot, or at least two meaningful strategies. And it is to go over the whole first row and only go down at the end, or immediately go down and eat up everything that remains on the second row. So the first robot doesn't want to maximize his score. He wants to minimize what the second robot can get, which is he wants to minimize the prefix on the second row and the suffix on the first row on the position at which the first robot is looking. And since the second robot will be taking the better of the two, the second robot will be taking the maximum. So the first robot wants to use a position which minimizes the maximum. And this leads us to a solution. We'll be maintaining, W is the width of the grid, we'll be maintaining the sum of the top row and the sum of the bottom row. So at first the top row is just everything on the top row, bottom row is nothing. And we'll be maintaining the result. So we start with some placeholder value. It's impossible to get the whole top row, so this is a nice starting value. And now for all the positions that we can take, so for every possible position for the first robot to go down, if the robot goes down on this position, then the second robot can either get everything in bot, so everything on the second row, on the bottom row, up to this position not including, so this is here, or he can get everything from this position in the top row, not including this position. So we subtract this position from the top row. We take the maximum of the top and bottom, which might be a new result if it's smaller than the old result. This is again a standard minimax, which is common in games where players take turns. One wants to minimize, one wants to maximize, so we have min-max, very standard. And only after that we add the current value of the grid to the bottom row to the sum of the bottom row for later processing. And at the end, we have looked at all the possible turning points. We just return the result, which is the one that minimizes the maximum over the two choices that the second robot can make.